everybody, this is Dr. Collins again. So I'm back with the second of our two t-test videos. So today we are going to be looking at, again, t-tests, this time looking at dependent samples t-tests. All right. Here you see this is related to our running example, Hillary Clinton's favorability ratings, going all the way back to when Bill Clinton started running for president in 1992. Okay, so you'll see there, right, that there's a lot of fluctuations. Her high is 67, and that comes towards the end. People sort of felt bad for her. They gave her really high reviews. You can also see that her favorability, of course, spikes right there around the time that she's Secretary of State, okay, right after she decides to become Secretary of State. Then you can see it declines pretty drastically as she starts leaves the public eye, and then starts running for election, okay? And then all the way out into 2018 where it's still really low. All right, so that's one of the things that we're going to be looking at today is Hillary Clinton's favorability. So agenda is literally the exact same as before, all right? And you can see here that I have her book here from after the election, What Happened. Again, she's sort of the theme of this week's slides, so I figured I'd include that. So let's talk about our example. Often, the losing candidates in presidential elections will see their favorability improve after losing an election. This happens to most losing candidates. It happened to Mitt Romney. It happened to John McCain. It happened to John Kerry. It happened to Al Gore. It happened to Bob Dole. It happened to George H.W. Bush. And, of course, Ross Perot, oddly enough. Right? It's very, very common. Right? Why? Well, maybe people feel bad for her or him, right? Maybe they feel bad that they lost the election. A little bit of sympathy goes a long way. It improves their favorability rating. Another possibility, right, is that maybe that person no longer threatens your guy or your candidate, and therefore you don't really feel threatened by them. You don't have as unfavorable an attitude towards them, right? So Obama voters, after Romney lost, would say, well, you know, he ran a good campaign. He kept it kind of clean. It wasn't really vicious, at least not from him. It was from some of the super PACs, but not from him. And, you know, we feel bad that, you know, he lost pretty badly, but, you know, he's not a threat anymore. So we feel okay. All right. So maybe that's it. Right. So maybe individuals become more favorable. Right. Maybe that's what's driving this. You're curious to know about whether or not this same pattern occurred for Hillary Clinton. Right? Whether individuals change their attitudes towards her after she lost the election. Well, thankfully, you have the pre and post 2016 election ANES feeling thermometer ratings for Hillary Clinton. Okay, so they ask, survey, it's actually, they run from all the way in March up to the day before the election, November 7th, 2016. And then they start asking again, starting November 9th, the day after the election, into January of 2017, before the inauguration. All right, so they asked the same people, over 3,500 of the same people, before and after, what their attitudes were towards Trump, towards Clinton, towards Stein, all these other things. So when you're looking at SPSS and you see in the label for a variable, pre or post, that's what that means, right? Did they conduct this question? Did they ask this question before or after the election? Okay, that's what it is. So we have data that we can use to look at this, to see if individuals shifted in their attitudes. So again, here are the steps. Just a reminder, we define the null, we set the threshold for significance, we select the appropriate test statistic, we calculate it, we determine the critical value, we compare the two. Okay, so that's nothing new, just a reminder. Hopefully this is getting drilled into your brain. So steps 1 and 2, very similar to the last video. If we think there's a difference between the Clinton feeling thermometer pre and post-election, we have our alternative hypothesis. So the mean pre-election is not the same thing as the mean post-election. So the corresponding null would be that the two are the same, that there's no movement before and after the election. We set our preferred significance level, again, identical to before. Standard choice should almost always be a two-tailed p-value of 0.05 or less. 5, which actually, because a t-distribution is perfectly symmetrical, a one-tailed test where p is 0.05 is the same as a two-tailed test where p is 0.10. So p is 0.05 in a two-tailed test is the same as a one-tailed test where p is 0.025. Okay. Typically, it's best practices to use the two-tailed, so we're just going to keep using that. So we choose our right test statistic. We have ratio level dependent variable. We kind of have a nominal or dummy variable, and that's treatment, right? Pre-treatment, post-treatment groups, where treatment is the election outcome. So which test do we use? There's our flowchart from the textbook. This time, however, we're going to look over on this side. Are the same participants being tested more than once? Yes. How many are we dealing with? 2, so we use the t-test for dependent samples. The key is that it's the same group. All right. Everyone in the first group is also in the second group. Remember, in an independent samples t-test, there's no overlap. In this, there's perfect overlap. Okay. If it were different groups tested on the same question at the same point in time, it requires an independent samples t-test. Again, sometimes this is called a difference of means test. Nothing new there. So let's look at our sample test statistic. There is our mean transgender feeling thermometer from before the election and after, along with the corresponding n. Notice the n is the same for both. Standard deviation, somewhat different. Standard error of the mean, very similar. Okay, because the standard deviations are similar and the n's are identical, standard error of the mean is going to be very similar. Okay, now we follow the formula. Here's the formula. This looks different, right? We don't see any s's, we don't see any n's, we don't see any x's, we don't see any standard errors here. This is very different than what we are used to. All right, D in this case is the difference in each individual score from time 1 to time 2. So we're actually looking at how someone changed from one point to another. Okay? So the numerator here is just the sum of all of that change. All right? And you divide that by the square root of the function n times the sum of the squared change. So some people want less, some people want greater. You just want the overall change. That's why you square it. And you multiply that by n, minus the sum of the individual one squared, which will also be positive, right? But it's going to be a smaller magnitude because a lot of those positives and negatives will cancel each other out within the parentheses, divided by n minus 1. Okay? So what you're really doing here is you're basically looking at something kind of like a deviation. Right? Remember, in a standard deviation, you look at the score minus the mean. It's kind of what you're doing here. All right, so it's not too crazy, right? But generally speaking, right, it's not something you're super familiar with yet. Now, this is a nightmare to do by hand, even with 5 observations, much less 3,588. Okay. Now, theoretically, you could go into SPSS and compute a new variable, right, which is equal to individuals' values of the pre-election minus the post-election, or actually it's vice versa, post-election minus pre-election, okay? And then you'll get a new variable where the value is that individual respondent's difference, all right? And then what you can do is you can compute the summary of that, the sum of that, adding all those up, and that'll give you the sum of D. Then you can compute a new one, which is that one squared, which is, and then sum that, and that's the sum of D squared. And then you can manually calculate this based on that, right? But doing it out by hand is a nightmare. Your textbook shows you how to do it. Feel free to do it if you want to. I'm never going to make you do it, okay? Because I'm nice. SPSS, I ran it through SPSS because I ain't doing this by hand, tells us that T here is 5.324. Already, some alarm bells should be going off based on the last video. What did we need a t-value of if our n was greater than 100? If our degrees of freedom was greater than 100? Any guesses? Right, 1.98. And really, once you get over 1,000, it's 1.96, just like a z-table, all right? Just like a normal distribution. This is greater than that. Already, you should be seeing, if you see a t-score greater than 2, probably significant, assuming you have a sufficient sample size, okay? We need the degrees of freedom. In this case, it's just n minus 1. All right, so T with 3,587 degrees of freedom is 5.324. Determine critical values. We have over 100 degrees of freedom. It should be 1.984 or greater. Ours is 5.324, so the magnitude is greater than the critical value. Since our t is greater, we can reject the null. P is in fact less than 0.000001. So we can reject the null that the two means are the same. Okay? We can rule out that the increase from Clinton's pre-election feeling thermometer to her post-election feeling thermometer is due to chance. That's all that means. So some concluding thoughts as we wrap up our unit on t-tests here. Generally, the dependent sample t-test is used for experiments, pre-treatment versus post-treatment. Okay, so in this case, our treatment was the election. Of course, other things might have come out about Clinton between then, but generally speaking, right, this is what we're looking at. Independent sample t-test is actually far more common because experimental research isn't as common in political science. Note, however, that this tells us nothing about causation in an independent samples t-test. It only shows an association between two variables. Apologies, the garbage truck is outside. It will be a little bit loud for a moment. Now, this is, of course, not necessarily true in an experimental setting. If you have controlled lots of things and you administer the treatment and you do your pre versus post-test dependent samples t-test, you're probably looking at causation, okay, assuming it's a properly conducted experiment. Now, after this point, your textbook moves on to comparing groups to look for examining means across many groups, not just two. That's called analysis of variance, often referred to by its acronym ANOVA. However, ANOVA is really uncommon in poli-sci research. So we're going to skip it. It's pretty common in education research. It's somewhat common in public policy and public administration research. Not really, though. Still, regression is going to be far more common than any of that. So we're going to skip it. Okay. Instead, we're going to focus next on looking at relationships between two nominal or ordinal variables. So up until now, with our t-scores, we've been looking at means, which implies we're looking at interval or ratio level dependent variables. We're going to move on now to looking at where we might have ordinal or nominal dependent variables as well as independent variables. Okay, so we're going to use the chi-square test of independence, which is going to be the video for Thursday. So again, please feel free to reach out. Let me know if you have any questions about any of this material. I wish you all the best of luck in the rest of this quarantine phase. Please don't hesitate to reach out. All right. Bye.